Let's talk about rational expressions. A rational expression is the quotient of two polynomials. Say ax plus y cubed minus 3 divided by 2b plus y. Since we're dividing by 2b plus y in this expression, it only makes sense if 2b plus y is not equal to 0. If we do have 2b plus y equals 0, then these values of b and y are excluded values. So we don't consider these values to be part of the domain of this rational expression. Just like fractions of numbers, fractions of polynomials can be simplified. Say we have a rational expression x plus 3 divided by x squared plus 5x plus 6. The first step to simplifying an expression like this is to factor the numerator and denominator. So the numerator can't be factored, but the denominator is x plus 2 times x plus 3. Since 2 plus 3 gives us 5 and 2 times 3 gives us 6. Now we have the same factor appearing in both the numerator and the denominator, so we can cancel them. X plus 3 goes away here and here. And what we're left with is 1 over x plus 2. We don't have to worry about x being minus 3 and this not making sense, because that's not part of the domain of this rational expression to begin with. Now, since 1 and x plus 2 don't have any common factors except for 1, and possibly minus 1, this is in simplest form. Now that we understand a new kind of expression, let's try multiplying these. Say we have n squared over 2n plus 2, and we want to multiply this by 6 over n. The process of multiplying these is actually pretty simple. The first step is to multiply the numerators of both sides. So on the top we'll have n squared times 6, and on the bottom we'll have 2n plus 2 times n. And next we want to simplify. Since we're trying to cancel out factors on the top and bottom that are the same, we actually don't want to expand out these products. We want to factor them. So at the top, 6n squared is fine. And on the bottom, we can take this 2 out of 2n plus 2 and write it as 2 times n plus 1 times n. Now first, let's deal with the numbers. So 6 has a factor of 2 in it, which will cancel out with the 2 in the denominator. So we'll be left with 3 in the numerator. Now n squared is 2 copies of n, and on the bottom we have 1 copy of n. So one of those will cancel out with the n on the bottom, leaving us with 3n in the numerator. And in the denominator, all we're left with is n plus 1. Now 3n and n plus 1 don't have any common factors, so this is in simplest form, and we've successfully multiplied these two rational expressions. Next, let's take a look at dividing rational expressions. While this may seem more complicated than multiplying, it really isn't much different. Say our problem is 2x over y divided by x squared over 2y cubed. Now dividing two quantities is the same thing as multiplying the first one by the reciprocal of the second one. And since the second expression here is a fraction, to take the reciprocal we just flip the numerator and denominator. So this is just equal to 2x over y times 2y cubed divided by x squared. And now all we need to do is multiply. So in the numerator we'll have 2 times 2 gives us 4. We'll have an x and we'll have y cubed. In the denominator we'll just have x squared and y. Now let's simplify. We can cancel the x in the numerator with one of the x's in the denominator. So we'll have an x left over in the denominator. We'll have the 4, since there's no other numbers, and then y cubed will cancel 1y with the y at the denominator, leaving us with 2 left. So we'll have 4y squared over x, and that's in simplest form.